Welcome my dear children to the first module of today. In this module, from the chapter Thermal Properties of Matter, we will be discussing about latent heat, heat transfer and Newton's law of cooling. In the last class, we had studied about specific heat. Latent heat is defined as the heat that is absorbed or released during a phase change. That is, if the substance changes from solid to liquid or liquid to gas, the heat absorbed can be called as latent heat. Latent heat is given by the notation L. The latent heat can be of two types: latent heat of fusion and latent heat of vaporization. Latent heat of fusion is the heat required per unit mass to change from solid state to the liquid state. And latent heat of vaporization is the heat required per unit mass to change from liquid to vapor state. It is a common experience that the burns that we get from steam is rather painful compared to the burns that we get from boiling water. It is because latent heat of vaporization has got a higher value compared to the latent heat of fusion. Here is a graph between heat and temperature. You can see that initially the amount of heat supplied to a solid increases its temperature. Then when it starts the phase change, that is from solid to the liquid state, the temperature remains a constant as indicated by the parallel line. Again, after the entire substance gets changed into liquid state, its temperature starts rising. Then, when all the molecules acquire the same temperature of 100 degrees centigrade, then it starts changing its phase from liquid to gaseous state. During this time also, temperature remains a constant. Now let us briefly discuss about heat transfer. Heat can be transferred by different modes, namely conduction, convection and radiation. Conduction usually takes place in solids, convection in liquids and gases, and no medium is required for radiation. Now let us see briefly what is meant by conduction, convection and radiation. Conduction is the flow of heat through an unequally heated body from places of higher temperature to those of lower temperature. Conduction is without the actual movement of the particles. Convection is defined as the transfer of heat by the actual motion of the particles of the medium. Radiation is a mode of heat transfer in which heat travels from one place to another without any intervening medium. That is, sun's rays reaches the earth by passing through vacuum. Now let us see what is meant by thermal conductivity. Thermal conductivity is defined as the heat energy transferred in unit time from unit area having a unit difference in temperature over unit length. It is expressed as joule, expressed in joule per second per meter per degree centigrade, or watt raised to -1 Kelvin raised to -1. Now let us discuss about Newton's law of cooling. It states that the rate of loss of heat of a body is directly proportional to the temperature difference between the body and the surroundings, not more than 40 degrees centigrade. It is a common experience that if something is served hot, then after an interval of time, the thing gets cooled. It is because of Newton's law of cooling. Now let us see a graph between temperature and time, which is related to the Newton's law of cooling, and it is known as the cooling curve. From the graph, it is evident that as the time increases, the temperature of the object decreases. It decreases steadily in the initial stages, and as the temperature difference between the system and surroundings goes on decreasing, the rate of cooling also decreases. This is the apparatus for getting the cooling curve, which is known as Newton's law of cooling apparatus. In this apparatus, we can see that we have got a double walled enclosure, and inside which we have got a calorimeter, a stirrer and a lid. And inside the double walled enclosure and also inside the calorimeter, we have got two thermometers. And as we had discussed earlier, we are going to determine the rate of loss of heat. We will be noting down the readings of the temperature from the calorimeter and also the enclosure at different intervals of time. And if we plot a graph of temperature versus time, we will get a graph similar to the cooling curve. Hope you might have got an idea about cooling curve. Heat transfer and latent heat. Thank you, dear students.